Let me take this opportunity to welcome you to the Aggies event that's been sponsored by Facebook. This is the final presentations where all of the teams are going to get a chance to tell us the things that they have been working on over the weekend. We've had just over 40 students engaged in 8 different teams, so you're going to get a chance to see a wide variety of how teams have solved various problems. They've been working on problems that Facebook has provided to make sure that we are solving something that is really a live, real worldwide problem. Each team will get 10 minutes. They will get a chance to spend and talk to us for 10 minutes about their solution and what problem they actually solved. Then we'll get a chance to hear from the judges. The judges will get 5 minutes for questions. We will tightly control both of those times. So the teams will get 10 minutes and then we'll cut them off after 10 minutes. And yes, judges, I'm going to cut you off after 5 minutes as well, because some of these things are very interesting. I've had the pleasure, along with a number of other people on the call, of working with the teams throughout the entire weekend. So we are very excited to have them show what they've been able to accomplish, because it is really amazing. So thank you again for everybody that's been here. I'll give a few thank yous along the way, but I want to start out by just thanking the mentors and thanking VJ in particular, and because he put together a tremendous team from Facebook, put together a tremendous set of need statements that we could work on over the weekend. And VJ has been a constant support throughout the entire weekend. And I really want to appreciate what he's been able to do for us. So what I'm going to ask the judges to do now is to turn on their video. And actually, in 1 second, students, here's what's going to happen. When it becomes your opportunity to present for you as a team, we will elevate you to panelists. When you become panelists, you will have an opportunity to turn on your video. As we talked about before, we'll be sharing your slides from here, and we'll start whenever you are ready. When we have the first slide up, what we'll do is somebody will come off of mute and say, all right, we're ready to go. And then you can start your presentation. That's when your 10-minute will start. As you present, if you want to turn on your video so we can see you when you're presenting, that's great. But everybody else, please keep muted and keep the videos off. The judges are going to keep their videos off as well, and so will I, so that we see your screen. Then what we'll do is everybody's going to turn on the videos at the time for the question and answer. That way the judges get a chance to see you and you get a chance to see the judges as well. So that's the process that which we're going to go. All right, so let me now pause for a second and let me ask the judges if they would turn on their video, all of them at the same time, so you get a chance to see who the judges are. And then I'd like each one of y'all to introduce yourselves so that the students get a chance to know exactly who is the judging panel today. So thank you all very much. All right, DJ, do you want to lead us off?
Absolutely. Welcome, everyone. We are super excited to hear all the presentations. I'm DJ, and I support open ecosystem activities within Facebook. And I can't wait to hear all the presentations and wish you all the best.
Thank you, DJ. Since I'm going to use my screen in the order in which my screen shows up, VJ, you are next.
Hey everyone, sorry I was having a little technical difficulties with the mute button. My name is Vijay Maniam. I support the hardware team here in Austin, Texas.
Great, thank you, Vijay. All right, Damien, you're next.
Hi, I'm Damien Chong. I'm happy to meet all of you virtually. I'm the hardware engineer in Facebook Austin, responsible for server design.
And that is an old server location in the background of Damien today. So it's
this is our data center.
That's right. Okay, Tiffany, you're up next.
Hi, everyone. My name is Tiffany Jin. I am a mechanical engineer on the hardware team at Facebook, and I am based out of our Menlo Park location, which is in California.
Thank you very much, Tiffany. And Yin, you're up next.
Hello, everyone. Nice to meet you. I'm Ying. I'm Ying Hong. I'm a senior engineer in hardware engineering group, and I'm based in Austin. Good luck on your presentation.
Great. Thank you very much. As you can see, we have quite a panel of judges. So students, as we said before, bring your A game. All right, what we're going to do now is ask everybody to turn off their videos and we'll share the first presentation. The first presentation is T-racking. And whenever T-racking, whenever you see your presentation up, then you'll get a chance to start, and that's when we'll start the time. And I'm getting the hi sign to wait for just 1 second. And we'll use this as an opportunity to remind everybody that Texas A&M University is incredibly proud to be able to host these kinds of events. This is the 38th event that we are able to do. All right, so I've got the hi sign that we are ready, and now they're going to share the screen, and we're going to be ready whenever you are.
Howdy, we're T-Racking, and my name is Ranjit Rajendran, and I'm joined here today by my colleagues Amran, Samyukt, Mohammed, and Pranav. Next slide, please. T-Racking is reimagining the way people commute in data centers by minimizing dead time to find a golf cart. So here's a quick video on what T-Racking looks like and how it could add value to your life. Next slide, please.
Facebook is in damage control this morning after suffering the worst outage in its history.
On March 13, 2018, Facebook and its subsidiaries suffered their largest outage ever. Facebook, the platform that allows 2.3 billion users from all over the world to share their ideas, simply left the world unconnected. Facebook data center technicians are the first responders to resolving these issues, often having to travel from one end of the data center to the other. Because of the size of the data center, the preferred form of transportation is golf carts. However, as of now, there is no way for employees to locate a vehicle, much less find one that is charged. In fact, every day a single technician wastes about 30 minutes looking for functional golf carts, preventing them from quickly responding to problems throughout the campus. These include data center outages, which result in a loss of approximately $24,000 per minute, and server fires, which result in replacements costing thousands of dollars. T-Racking is the solution to this problem. The T-Racking app provides Facebook employees with information about nearby functional golf carts. First, attach a T-Racking device to the vehicle. Now, just go to the website or open up the app and you can view the status of all the golf carts on campus. Don't waste time searching for golf carts. Just T-Rack them.
Next slide, please. The problem we are solving is the need for a system that enables data center employees to quickly locate working vehicles to speed up commute. Next slide. So data centers are large. Often the problem arises from the fact that data centers are large, often encompassing over 1 square mile. So as a result, 10 to 20 employees at a given data center require the use of golf carts to commute from one end of the data center to another. Each of these employees uses golf carts about 3 to 6 times per day, each time searching for a golf cart for about 5 to 10 minutes. In total, this results in a waste of 5 to 10 production hours, which can be especially detrimental during a server outage, where minutes are worth thousands of dollars. Next slide.
While designing our product, we envision our product to have a simple UI, to be scalable, to be cheaper than most available solutions, to be resilient against the environment, and to be energy efficient. Next slide.
For the system design, we choose for a centralized approach, which we figured out to be most energy efficient in terms of communication, by doing creating a gateway that is attached to the edge of a building that communicates to the devices in each of the golf carts. The gateway is connected to a cloud database that is accessible by application or the web portal through an API. For the long-range communication, we used LoRaWAN technology that can cover more than 5+ miles, depending on the frequency band. Next slide, please. So as As taught in last slide, the centralized system which we chose is simple and effective for the scale of problem that we are trying to address. There are other solutions like distributed system in which the cards have a distributed network among themselves that they talk among each other, which is complex and expensive. And last but not the least, there are user-dependent systems in which a user will report to a centralized entity after using each card, but that requires the user to do the work. So we did not go that way. Next slide.
Following the requirement analysis and the system design, we grabbed available components within our reach and quickly built a product prototype. Our solution does not require any infrastructural investment and mostly leverages what is already there. Here is what a prototype looks like on the left top. It seamlessly connects all the cards to the server through a gateway module. The server provides an API for further intervention by application. Finished product would look like as simple as the picture on the left bottom. Next slide, please. We also built a prototype based on the available product that we had. The cost estimation of our product is $77 based on what we used. We estimated the cost from the available market material, which would be $37. If we build an unified mass production model, which will reduce the cost in a significant level. Next slide, please. There is a software prototype that we built as well. So we built two fronts. One is the web portal and the other is the mobile app. The web portal gives you access through the API to the server. The mobile app can also be integrated to the Facebook's internal application, also accesses the API and connects to the server, which is also connected to all the cars available, and users can easily get the location information and the battery health. Next slide, please. We also compared our technology or our solution with the two most famous available technologies in the market. The one is Gotenna and the other one is Tile. If you look at the chart, comparison chart, our product beats them in every single level. If we talk about two particular important criteria like range and the power that we're using, our product supports low range. Tile doesn't, though Gotenna supports long range, but it is based on a mesh network, which is not feasible in Facebook data center. And in terms of low power, if you look at the chart on the left, the technology that we are using uses the lowest power and costs the lowest. Next slide, please.
So what makes us unique? This is where the innovation comes in play. And we have pointed out 4 different aspects in where we are unique and innovative. First of all, our devices on the golf cart are location aware. The onboard GPS can track location and the movement of the golf cart down to meters and can notify the gateway. Second of all, algorithmic battery estimation. We propose that we do not require any additional hardware to estimate the battery of the golf cart. We can estimate the battery based on how much the golf cart has moved from and to the charging station. Third, repurpose scrap hardware. We want to repurpose the scrap hardware from the data center, the hard drives. It contains metal and magnetic components that can be repurposed and made into a protective alloy that can be used for the protection of the device. Lastly, minimal battery usage. Our devices incorporate minimal battery usage. In other words, our devices do not communicate to the gateway when the carts are not moving. In that way, when the system is not being used for several days, the battery is still intact in our devices. Next slide, please.
SWOT analysis. First off, we have strengths. It's user-centered, easy to use, and it's able to withstand through harsh weather conditions. The only downside is that Facebook would be paying for it. As for opportunities, Facebook, or honestly any other company, is able to, or we would be entering the IoT market. We're able to reduce repair expenses, reduce service downtime. Now with threats, obviously there will be other competitors out there. So that's something to be more cognizant about. Next slide, please. Risk mitigation plan. If we have demand, if our demand in T racking is low, we're going to gather user feedback to improve. No phone, no problem. We have a physical dashboard on the golf cart itself. And finally, financial risk. There is a small investment fee. Next slide, please.
So let's ask the real question, but when does my life really get better and how soon can I get my hands on this new exciting technology? The first thing we're going to do is speak to server technicians and network side managers, and essentially people who live and breathe in this chaotic environment. They're going to tell us and give us real insight into what we could do to add more value. Next, we need to test the product in a real setting and understanding how well the users are accepting this new technology. And hopefully by the end of next year, we plan on seamlessly deploying our technology in a low-risk, small-sized data center while not disrupting the business workflow of the campus. And from that, sharing insights from our analytical models on how people use the carts and harness that information to reallocate golf carts amongst buildings. Next slide, please. So what's next for T-Racking? Our platform directly reduces downtime by about 8,000 work hours per data center. There's about 15 data centers right now, and new ones are being built in Tennessee and Oregon as we speak, so the numbers are only going to rise. The soul of our project is about keeping the user at the center of it, and how we can add positive value to their life and continue to do so. Moving on, the most exciting aspect of our product is that we can expand it to all 15 data centers and even beyond Facebook, as Brittany mentioned, because it's platform agnostic. Finally, now more than ever, it's more important to create a lasting,
All right,
sustainable
T-Racking,
impact.
thank you so much. Thank you very much for your presentation. That was 10 minutes. And judges, you have
Thank
5
you.
minutes for questions.
Hello, Zizi. Thanks for the presentation. I have a question regarding, like you mentioned, for your solution, you have the low battery compared with other like established solution. Also, it's a sustainable. It can sustain the harsh environment. Do you have any evidence to show like you have this kind of function available?
Yes, for the low battery usage, we are planning to incorporate an algorithm so that the battery, the device only communicates to the gateway only when the carts are moving, because we can know when the carts are moving by the GPS locations that we have. So compared to other solutions like Tile and GoTenna, based on my own experience, they can only last like for a few hours. But if we, in our cases, since the golf carts are not extensively being used the whole time, so for one charge with a good capacity battery, it can go for more than 10 to 15 days.
Hi,
about the harsh environment? Do you have any evidence on that one?
So we took into consideration the fact that the data centers are located in different regions. So there are environmental aspects like some areas are too hot and some areas are too cold. So in that case, we looked for the protective casing and what kind of material that can be used. Then we figured out that it needs to be rugged and it needs to be heat and cold protected. In that case, we figured out that aluminum is lightweight and also at the same time is strong. And also there is another material that is neodymium magnet. This magnet can be made into an alloy and created a protective case. And surprisingly, both of these components can be found in a hard drive that are burned off from the data center. So it's a point where we can reuse the materials that are being taken out from the data centers and considered as waste.
Thank you.
Hi, I'm DJ. I have a quick question. You mentioned that employee downtime saved is 8,000 hours per data center. Can somebody quickly run through how you came to that number?
Yeah, so I think after speaking with our mentors, we kind of estimated about 30 minutes per day is being spent by each data center technician, which sums about thinking about assumption. The key assumption we made is about there's 20 technicians in each data center. So we came up with a range about 5 to 10 hours per day in just one single data center. So kind of rounding that up across the 15 data centers and estimating that across the year annual period is when we came up with the rough estimate of 8,000 work hours.
Right. So 8,000 is per data center or across all data centers?
It's actually per data center, but then across all the whole across all the technicians within the data center.
Got it. Thank you.
Thank you.
So I had a
It's
question. Oh, sorry. Go ahead, Damien.
Okay, I'll go first. Hey, this is Damien. I just now heard that this is battery-based design, and how it's being charged. And just now you briefly mentioned about it lasts for 15 days, answering one of the Yin's question. But yeah, my question would be how long will it last in standby and during use?
So I'll take that. So our solution is off the shelf, is made by off the shelf hardware. We had battery and we incorporated in our prototype to demonstrate that the device can run with the battery. And it's true that currently it's, the battery needs to be charged, but our solution is not limited with the battery because it can easily be integrated to the golf cart battery, depending on the particular data center and the implementation of the data center. So just to be clear, our solution is not limited to the battery usage and the battery component that we use with our device.
Just to add on to what Mohammed said, I think another aspect of it is gonna be optimizing the battery life of the golf cart. So using the analytical models we mentioned, we're gonna get data from it, kind of gather insights about which locations kind of need the golf cart the most. So trying to keep it as accessible to the most frequently, like the blast radius, for example. Try to keep it within those sites kind of definitely help us kind of minimize and optimize our product itself. So I think there's a broader scope.
You have time for one more quick question and a very short answer.
Yeah, so expanding it's beyond the scope of the project as well. So we can expand it across different dimensions. Thank you, Damien.
Okay.
BJ, did you have a quick question and a quick answer?
Probably not, so I'll defer.
Oh, okay. All right. Thank you very much, T-Racking. And we will move into the next team. Thank you very much for your presentations. And we will be in the process of moving you.
Thank you for your time.
Back to
Thank you.
participants.
Thank you, judges. Thank you, everyone.
Thank you.
Thank you, Rodney.
You bet. The next team will be Team Pizza Power. And so that actually inspired me for my dinner last night. So that's what I had for dinner because Pizza Power was inspiring me for my dinner. While we're getting them ready and getting their presentation ready, let me spend a few minutes talking about engineering entrepreneurship and the engineering incubator that we have available to all students. As you see, we have some very innovative solutions being proposed and presented today. We want to make sure that all of you recognize that we have an engineering incubator as part of engineering entrepreneurship. Our program is set up to be able to allow you to be able to turn on and create a startup. We have all the resources necessary for you to create a startup and all the resources necessary to help you. We also can provide some limited funding. We love to work with teams that are continuing on and as part of Aggies Invent, and we love to continue to work on with teams and helping you develop these startups. As also, I'll talk more about engineering entrepreneurship as we wind up going through the presentations, but it appears that now we have everybody ready. And Pizza Power, as soon as we have your presentation shared, then when you start, we will start the clock on your 10 minutes. We look forward to hearing your presentation.
Thank you.
Good afternoon. We are Team Pizza Power. My name is Thomas Sims. I'm a sophomore electrical engineering major.
I'm Jennifer Yen, and I'm a junior computer science major.
I am Zachary Rankin, and I am a senior ESET major.
My name is Jacob Milford, and I'm a senior MMET major.
I'm Joshua Swafford, and I'm a freshman in general engineering.
And this is our engineering design. Next slide, please.
Approximately 42% of Facebook's revenue is dependent on their iOS app portfolio. These apps must be developed and tested on iOS firmware, primarily using Mac Minis. Unfortunately, the standard server racks do not support the required 110 VAC power source for the Mac Mini. 5,000 of these racks are being added annually, and the current solution on directly wiring each of these is unsustainable, and redesigning the standard rack to support 110 VAC requires at least a year's worth of engineering resources. Furthermore, these server racks are continually being upgraded, and a new rack today will be obsolete in the next 3 to 5 years. We have designed a flexible solution to fix this issue. We have designed a modular add-on to existing server racks which provides the needed 110 VAC as well as easy plug access. Our design consists of two main components, the converter and the distributor. The converter replaces the existing power supply, outputting power to both the DC power converter and the 110 VAC needed for non-standard racks. The distributor is a bar fit along the back frame of the existing server racks, which provides blind connectors for the servers to connect to. This alternative solution to providing power to the Mac Minis will save upwards of a year of development and can easily be transferred to future versions of the server racks. Additionally, this module will eliminate the need for custom wiring jobs for new servers, which will in turn speed up the integration of new racks. Powering you to power the future.
Next slide, please.
So the problem we chose was how to enable flexible deployment of non-standard infrastructure in Facebook data centers. Next slide, please. Approximately 90% of all Facebook revenue stems from mobile ads, and 45% of that comes from the iOS portfolio. iOS testing must run through MacBook Minis, which uses a power source of 110 voltage AC, which is unsupported by the current rack design. This forces Facebook to design custom server racks for case-by-case situations, which is both costly and inefficient. These racks will take 1 to 2 years to develop, yet only have a service life of 3 to 5 years, so a modular solution would be more flexible and future-proof. Any delay in iOS development would have disastrous impacts on future productions. Next slide, please.
As requirements for our project, we have modularity. Our project needs to integrate easily with existing and future designs for racks. Next, it needs to fit with the existing server racks. This is both dimension-wise and has to do with the thermal systems that are already in place. Next, we need to have simple installment. The easier and simpler and faster the installment, the easier maintenance is and easier replacement is if there's any sort of issue that arises. Next, we need to have safe connections. We're working with high currents here, and that can be dangerous, which is both a liability issue and more importantly, an employee safety issue. And finally, of course, we need to provide that 110 VAC power source that powers our Mac Minis that we need to use in order to keep developing one of Facebook's biggest revenue streams. Next slide, please.
As part of our solution, we designed an AC converter. The converter takes the source current and divides it into 3 outputs, 2 outputs being for the power rack and 1 output being for the 110 VAC to power the non-standard servers. Our converter will be placed at the top of each rack and draw its power directly from the source. This positioning allows us to efficiently distribute the power to the individual racks without needing to worry about natural current divides between the racks. This enables us to reliably power all of the servers on a single rack with the required voltage levels. Next slide, please.
Howdy. As previously shown, our distribution strip is used as the preferred means to be able to transfer the desired 110 VAC to each server bay. Our distribution strip is a simple and efficient solution applying these power needs to current and future non-standard server racks. The distribution strip will be mounted on the back side of the server rack using the pre-existing mounting points on the rack itself. For the server to receive the power, we included a female blind connector on the distribution strip so that the server technician slides the server into the selected bay. The server with the male connector on the server will automatically mate and make a power connection. This is important since using this method will enable a simple drop-in solution, so no extra modifications will be needed to be made on the server rack. Next slide. In this graphic, we show both the converter and distribution strip attached to the current server rack. Both components will be easily attached and implemented into the current non-standard infrastructure. Being that the solution uses basic elements to fulfill the task, it is also designed to be very easily serviceable if the converter fails or a blind connector loses connection at any point in time. This is a perfect solution that fulfills Facebook's power needs for their non-standard infrastructure. Next slide.
Our design addresses the critical issue of the lack of 110 VAC in existing server racks. The modular design of our product is easy to add onto existing server racks and eliminates the need for a complete redesign. With its easy installment and serviceability, our module is future-proof and easily adaptable. Its simple and elegant design makes it the ideal solution to this issue. Next slide, please. These are our sources. Next slide, please. Thank you for listening to our presentation. We will now take any questions.
Thank you, Pizza Power. All right, judges, so you'll have 5 minutes for questions.
So a quick clarification. This particular solution you're proposing would operate as a retrofit into existing racks which might be deployed in the data center?
Yes, sir, that is correct.
Okay. Thank you.
Hi, this is Damien. I have a question. So just now I saw that it's more like a voltage conversion box. And why do you choose to have a different bus bar instead of using the existing one? Is there a reason for it?
So the bus bar that's currently being used for the server racks is like basically 2 parallel plates that runs through the whole back of the thing, and they're pretty much open. And the issue with that is if we include the alternating current, that's a lot higher and a lot more dangerous than the 10 DC volts, which are running on the back. So for safety concerns, we don't want to have that open bar exposed, which is why we have the recessed ports. And it's a little bit more difficult, but it's a ton more safe than if we were to run the current on those bars.
Yeah, good consideration. Thank you.
What did you assume was your input power? Was it 277?
From the data center?
Yes.
Yes. From our mentors, it's either a single input port of 480 or 2 inputs of 277. That is dependent on on the server location, and we plan to have both of the connections on top of the converter box, depending on which server location it is in particular.
Okay. I have 2 questions related to that. One would be, did you have a chance to look at alternative solutions that might be available off the shelf that might be able to do that power conversion? And then the second question would be like, what were you able to calculate like power efficiency of comparing the your solution to solutions that we may already have either available off the shelf or in the Facebook data center?
We do know, okay, go ahead.
Yeah, I'm sorry, can I take this one? But so we have looked at the power efficiency of the current design implemented, and it could be done better in the sense that we used a buck converter rather than the pull down resistor to drop voltage later on after the conversion happens. And part of the reason we came up with our own design for this rather than tying up the CAD again was just part of the proof of concept that it was in fact possible to do this within this black box. Compared to what we already could purchase, I would say no, the design is slightly less efficient than what's already available.
I would actually maybe concur on that because, and my understanding on the mentor, our mentor, the current solution to provide these 110 volts AC is they're using a additional power shelf within the rack that will convert the 12 volt DC back to 110 volt AC. So currently, by how our understanding of your current solution is, you guys are converting the 220 volt from the power shelves to 12 volt AC back to 110 volt AC at that point. So in actuality, we're excluding a conversion step from AC, DC back to AC to only AC to DC. I would greatly assume that would greatly improve efficiency in the current solutions.
So thanks for the presentation. I have a question regarding to like how have you think about how your solution connected with the chassis? Is that a specific design just for the Mac Mini? And then if that way, then how do you plan to connect with the chassis? Is that like a blend-made connector, or it requires some like a cable?
So the way that the Mac Minis are included in the servers is they're basically put inside a box which acts like a server. The only issue with that is that they take the different kind of current. And so our solution is we've taken the basic design for the server rack that's already there, and we've implemented direct add-ons to that specific server rack. So the Mac Minis still connect in the same way, but now they have the extra option to plug into that alternating current, which is the add-on. And that just, again, like we mentioned, increases the efficiency.
And Pizza Power, thank you very much for your presentation and for the great answers to the questions. We really appreciate it. All right, as we're transitioning into the next team, when the next team will be Team Engage, let me explain a little bit more about what's going on with engineering entrepreneurship. Our entire program is set up to help you augment your technical degree as you're working in developing a technical degree and working towards your bachelor's or graduate degree. What we do is we augment that with some additional business skills and additional product development and management skills, such that when you design something, you realize that there's a customer behind it. We have a series of classes. One of the classes that we have is a single-hour seminar class where we bring in 14 different entrepreneurs and realize an entrepreneur can either be starting their own company or it can be someone inside a company, because I will dare say that all of the Facebook mentors that we have and all of the judges that we have are actually entrepreneurs inside their very large company. And that's what everybody's looking for, is we're looking for an entrepreneurial mindset. So our first course is a seminar course where we have a number of entrepreneurs come in. And another course is about enterprise basics and how do you run a business. We're teaching a class right now on sales, operations, and manufacturing for high technology companies. And how do you have a sales force? How do you manage a company? And how do you put things together? So that's a number of different courses that we have in terms of engineering entrepreneurship. Of course, we host Aggies Invent, which is this 48-hour intensive design experience to be able to allow you to see what it's like to be able to investigate and innovate a solution to a problem in a very short period of time. And that's the kind of thing that most companies are looking for. All right, Team Engage, you are ready and you can get started as soon as your slide is up, shared, and ready to go.
Good afternoon, everyone. We're Team Engage, and we're super excited to be here with Facebook and Aggies Invent and present us our solution. Next slide, please. So my name's Jennifer, and I'm here with Brahim, Michael, and Mahmoud. Next slide, please.
Do you know that Facebook hardware team spends on average $18 million on meetings regarding goals every year? Currently at Facebook, goal information is not centralized, which results in inefficiency across the organization. What if we tell you that there is a way to boost efficiency by making goals more transparent? We designed Goalbook to help bring together all important aspects of goal information that tailors to the core value of Facebook. There are two main core values that we believe will change the way people collaborate. First is focusing on the impact. This technology impacts the company by increasing access to goal information that helps managers make more informed decisions. Second is be open. Goalbook is also catered to increasing transparency by allowing goal information to be readily accessible across all teams. Goalbook provides you the opportunity to prepare for the future in a more efficient and transparent manner by integrating technologies used today into one simple and effective platform. Goalbook. Efficiency is transparency.
So Facebook is a multi-billion-dollar company that connects 1.8 billion daily users across the world. It helps us to get informed of pandemic, of political protest, and also help promote small businesses. Next slide. Next. So our team is tasked with need statement 17. In order for Goalbook to focus on innovation, it is essential to reduce the friction caused by internal conflicts. And our team can help solve that by providing a goal tracking system that helps more efficiently track and plan goals. And now I'll hand it off to Mahmoud to talk about our problem statement. Oh, actually, next slide, please. And so currently, from our research, that our challenges that our hardware engineering team is facing are the three tasks. Number one is uncentralized goals repository. The second is task repetition. And the third is inability to track goals across cross-functional teams. And this leads us to our problem statement. And now I'll hand it off to Mahmoud for our problem statement.
Thank you, Jennifer. Next slide, please. So with all these challenges in mind, we came up with the following problem statement, which is goal information at Facebook is not centralized, which results in inefficiency across the organizations. Next slide, please. So that leads us to the value proposition of Goalbook, our application, and that is boosting efficiency by making goals more transparent. So we came up with this value proposition based on some of the discussions we had with the Facebook employees and based on a brief survey we set out, in which we found out that oftentimes in their projects, they're using multiple applications that are oriented around their goals, such as G Suite and Slack. In addition to that, at any given time, they're often tasked with 10 plus goals. So this can be overwhelming. So the idea with Goalbook is to centralize all those goals and applications into one thing and make the process overall more efficient. In addition to that, when talking to the Facebook employees, they really mentioned that a very critical thing in this process is to make goal resource allocation 100% transparent. And that's what Goalbook is really revolving around, that transparency and that efficiency. Next slide, please. So the design requirements we considered when coming up with this application was number one, functional goal management. We want to decrease goal making frequency by 25%. That's something we want to be able to measure when Goalbook is applied. Number two is goal alignment. So we want to get goal alignment in an efficient manner to improve goal alignment and manage to see 5% decrease in total hours spent on projects on average. Next is plugins. We want to seamlessly integrate Goalbook into 10 plus applications that Facebook is currently using. This includes Slack and G Suite to make it seamlessly applicable across the organization. 4 is capture resources for goals. So we really want to capture critical resources in regards to goals. This includes things such as hours, fiscal, and the team members required for each goal. And finally, the last design requirement you consider is dependency tracking. So we really want to track dependency with priority on all other projects. This priority includes low priority, medium priority, and high priority. Next slide, please. And here we considered 3 designs overall mainly. The first design we considered is a social media platform that incorporates goals. Next, we considered is a design that implemented machine learning to give goal recommendations. And finally, we considered the software that unifies goal information into simple views, which eventually became the work we focused on as Goalbook. And the reason we chose this over the other platforms is mainly because it really focuses on the information we want, which is simply goal information. And it really does that in a simple and efficient way, as opposed to social media or machine learning, which can be quite difficult for barrier of entry and ease of use. So that being said, I would like to pass this on to Brahim to talk about the UI UX of our application.
Thank you, Mahmoud. The user interface for Goalbook was designed to meet the value proposition of efficiency being transparency. This page we can see is the overview of the project. Here we can see all kind of key information about the project, usually managed by the manager. On the left, we can see that this is where you can interact with the project, go to different views, and also see other teams where they have dependency related to projects or objectives. In the center, you have a brief overview, the goal, etc., the people that are working with you. And below, you have a list of applications that are related to your project pulled through APIs and plugins. And on the right, this is where you see what everybody on your team is doing, keep a live track, and also join them if you want to collaborate. Next slide, please. As Mahmoud mentioned, the dependency is a very key part of Goalbook. Here, we can see all the kind of interactions between different teams. For example, the lab team working on a troubleshooting task or objective. We can see that it has a medium priority with the network team. So here we can see all the kinds of relationship between teams and what dependencies are related. Next slide. As mentioned, in order to boost efficiency of the product, we want Goalbook to be integratable with different apps that are already been used by people at Facebook. Some of these apps, as mentioned, are like the Google Hub, Dropbox, Slack, etc. Next slide. Next slide is the metrics view. This view is an overall centralized numerical formation of all the project statistics. This usually speeds up the process by having managers see all the statistics about their team easily. It also is very catered to different members, all departments. For example, if the sourcing department wants to come in and see what kind of parts the team needs, it will all be visible and catered to them here. Next, I'll pass it on to Michael to talk about our innovation. Thank you.
So we were able to gather some information based on the interviews and surveys from hardware engineering employees, and we made a comparative analysis with other systems that is currently utilized in the hardware workflow system. Next slide, please. In the future, we'll be able to develop more integrated factor that would allow us to build profiles of Facebook employees to be able to gather resources that would align with goals. We'll be able to use continuous design for integration and other applications as well. So we'll be able to build plugins into those apps that are currently being used. And we'll also use this perform this by adding statistical information and more resources into the system to analyze data in a more efficient and more effective way. Thank you so much for listening. I'll now open the floor for any questions you may have.
Thank you very much. Engage. Judges, you'll have 5 minutes for questions.
So from your presentation, it seems like the audience for your goal tracking app would be management. And then it seems like the people that would be inputting the goals would be a combination of management and engineers. Is that correct?
Yeah, that's correct. So usually the management would kind of create the page, invite all the team members in, and that's where they kind of work together to create a main goal that they want to work on. And then individually, each team member would kind of input their tasks and objectives.
How much time do you think that would take? Because as an engineer, the first thing that I would think was like, this is just one more tool among all of the tools that I have to work with, and it's just more time. How would you get people to engage in it and use this as their one tool?
Yeah, so we kind of looked at the overview of usually people at teams usually use their own individual apps like tasks, and the ability for them to kind of share what they do with other team members and ability to collaborate, etc. Usually that's kind of inefficient. That's what usually takes a lot of time. And having the ability for everybody to be under that one group, under that one category, seeing what everybody else is doing, easy to collaborate, etc. I feel like that's the main factor of the transparency, which is our value proposition, and also improve productivity.
And in addition to what my teammate just said, we'll be able to gather some more document, we'll be able to enable document consolidation on our app. So we're working with apps like Slack that you currently use, apps like Google Docs or the other softwares from G Suite into this system. So you'll be able to navigate easily and more efficiently to perform tasks.
So I have a question. By the way, Goalbook, I love that name. It's a pretty catchy name for a product. And I can see this as an interesting productivity tool independent of Facebook. The question I have is, you made a comment that your goal is to centralize the goals to provide more transparency. So the first question I have is, do you think it's even possible to centralize the goals in some sense, right? Because there are so many organizations. How do you centralize something which is already distributed in some sense? And then the second question is centralization necessary to provide transparency? Can you provide transparency without worrying about centralization?
Yes, that's a great question. To answer your question, currently they're across like different softwares that we can track our goals from, right? So for our platform, once we are able to provide that centralized platform, that provides the transparency. So think about like having 21 tabs open, trying to track an overall organizational goals. With our application, it's just going to be one platform, and that way it can easily track those goals. And also the dependency feature will help the managers be able to get more informed decisions out of the information.
So I had a question. I think one of the things you guys started off with on the presentation was that how long it takes Facebook engineers to put their goals together and how much time they're spending in meetings. So is there a target for how much this tool will reduce the amount of time that we're spending in meetings?
Yeah, one of the targets I was thinking about was decreasing goal-oriented meetings by 25% essentially. And this would save the company a lot of man hours and allow them to do much more impactful things. Like as Jennifer mentioned at the beginning of the presentation, you know, Facebook has impacted us mostly in terms of the way we view information, and we want the engineers there to continue to be impactful in that sense, as opposed to focusing on these mundane things. So the goal is to really have a big chunk out of those meetings. 25% is the goal, and I think that would bring a significant difference in terms of the value we bring as a product.
Okay, thank you.
You have time for one more quick question and a quick answer. Well, team, it looks like you've answered all the questions, so thank you very much. Appreciate it. Team Engage, great presentation, and sounds like you might need to go trademark that name. So think about doing something along those lines, all right? We'll get ready for the next team, which is PyTask, and they are going to be presenting on their project and what they were able to put together. As we were talking about before, the coursework and the part that engineering entrepreneurship provides, we also offer something that's called a C3 certificate. C3 stands for concept, creation, and commercialization. And the reason that it's called that is because that's actually what we as engineers do. We have a concept, and then we create the solution. Then you find ways to commercialize it. And if you will, that's exactly what we've been doing this entire weekend. Is you started out with a concept, you figured out a solution to it, and now you're in the process of helping us understand how to commercialize it and who cares about it. So the C3 certificate is a great way for you to document exactly what you've been doing and the skills that you have developed along the lines. It's a 13-hour certificate. 4 hours are required hours, and the rest of the hours, 9 hours, can be taken from a variety of departments or a variety of different classes. You can register for the C3 certificate along with the other courses and the other programs that Engineering Entrepreneurship offers. And don't forget about the incubator, because we just had someone launch out of the incubator and start their company. And it's been very exciting to watch. And we love to be able to start doing this. So engineering entrepreneurship is, yes, Aggies Invent, but it's also much more. It has an opportunity for you to engage throughout the rest of your academic career. We'll work on professional development skills, customer interview skills, presentation skills, and many of the things that we've taken a very quick look at over the weekend will help you continue to develop these skills over time to make you a much more valuable employee. And oh, by the way, don't forget, there's a resume drop in the general channel of the Teams environment, which gives you an opportunity to copy a QR code and then drop your resume so that the mentors and the people at Facebook have an opportunity to look at your resume and give you an opportunity for an internship or even potential employment. All right, we are now ready for Team PyTask. And as soon as you see your screen shared and ready to go, and you can start your presentation, and we will start your time whenever your presentation starts. So we look forward to seeing the presentation on PyTask.
Howdy, everybody. We're PyTask. Forget the previous group. This is the better idea. Why ask when you could use PyTask? We represent needs 17. Next slide, please. So first of all, we want to thank Matt and Ahmad for being our mentors. My name is Ignacio Sanchez.
I'm Hamza Iqbal.
My name is Yam Gupta.
My name is Bala Jeronimo.
I'm Shalab Babatunde.
And next we'll be showing you a video of before our product and after our product. Next slide, please. Hey, how's it going?
Hey, Ignacio, I've been all right. Just stressing out about this newsfeed algorithm my team has been working on.
Oh, really? Newsfeed algorithm? Wow. You know, my team's been working on newsfeed design for the last month. That's funny.
Huh, I wish I would have known that sooner. We've been having a lot of problems with the newsfeed display. It would have been really helpful if we knew to collaborate on that.
Man, I had no idea. I wish I'd have known that too. It would probably saved us a lot of time.
Hey, Ignacio, how's it going?
Hey, Hamza. I just saw you started a new project with the newsfeed algorithm.
Yeah, that's what I wanted to talk to you about. You worked on a similar project about 5 months ago, right?
Yeah, that's right. I can tell you about what approach we did and how we struggled with it. In fact, let me get you in contact with Vyom. He knows newsfeed algorithm very well.
Oh, thanks. I'm glad our company uses PyTask to keep track of these projects.
So as you can see, in an organization such as Facebook, connecting 3 billion people worldwide, there's a lack of goal transparency when in relation to goals. This can cause a lot of wasted resources. Next slide, please. So at Facebook, they have input and output goals. Pretty much input goals are goals that you do within a day, and output goals are kind of what you do in a longer scope. So from what we saw, there's a lack of consistency when creating goals, that there might not all be the same depending on groups, depending on the groups, projects, regions, and even if you're dealing with other vendors. From the backend goal, currently there's nothing that archives goals that are already completed. And then there is no real-time transparency between output goals, meaning workers might not know if other workers are working on the same kind of things within the same company. Next slide.
So we had 5 main design requirements for our solution. The first one is that it has to be open, meaning that it must visualize information for multiple projects. Second, we wanted it to be uniform, so it allows proper formatting of goals. And third, we wanted it to have a responsive design, so it's easily viewable through mobile and desktop view. And fourth, we wanted it to be attachable so that it supports users being able to upload different types of files, such as Word documents or Excel spreadsheets. And then lastly, we wanted it to be scalable so that it's able to showcase hundreds of projects. Next slide, please. So there were 3 initial designs. We chose design 1 over designs 2 and 3 because it was able to meet our requirements mentioned earlier more closely than. Next slide, please. So what is PyStacks? There are 2 main features. First, there's the keyword ranking software, which essentially clusters similar work. And next, there's the internal web application, which is able to display dashboards with project progress, in addition to curating the setting of goals. Next slide.
So why do we care about PyTest? There is a lot of time wasted when in the planning phase. We've heard that this can take from 1 to 3 months just planning. And then there's a lack of transparency within these output goals and more of our projects. This can lead to burnout. As an engineer, the last thing you want to do is go to another planning and goal meeting when you just want to work on the things that you really love doing. This can lead to stress and eye fatigue, especially times of virtual, like right now. Next slide.
So how does it work? Well, the user goes ahead and uploads their goal document. Within that, our code goes ahead and generates some certain highlighted tags, as you can see on the right. Based on the frequency of the tag usage, it's darker, and the user can actually add on more tags to give them more suggested projects they can link up with. Next slide, please. On the left-hand side, you can see a demo of a simple upload document. And this is what is on the right is what is generated after we look at the frequency chart, which is generated by the backend model. Next slide.
The user experience components consist of the home page, project display, and goal creation. The home page lists all the organization's different projects with the search bar and the project creator button. The project page involves in different lists of goals, along with who is responsible, hashtags, all the applications used, and time status. The goal creator includes our Python script, along with the specific project inputs. Next slide, please.
Now, when it came to this project, not only did we successfully meet all 5 of our design requirements, we did a user test with 8 individual employees from Facebook, 4 interns, 4 normal employees, and we had them do a test where they either went through a spreadsheet document like the one shown before given to us, or they used our tool in order to navigate it. All people who used our tool found all the information they needed faster than expected, and all of them also found new information of things that they would like to do with other teams that are related, something that was not present inside the control group. Next slide. This tool can be implemented into currently existing infrastructure at companies like Google and Facebook that have their own task management systems as ready. And it also works really well in academia and schools because it works well for peer feedback as well as research collaboration. And startups can use it easily for managing freelance projects and contractors. Next slide. And our next steps will include building a machine learning model into our Python script, as well as a new JavaScript input for managers to choose what is going to be a good idea for more important keywords, i.e. ideas for tags. And also, lastly, a login feature. It's necessary to make sure our product is usable and secure for any internal use. Next slide. Thank you so much for your time. And are there any questions, comments, concerns, or quarrels?
Thank you very much, PyTax. Judges, you have 5 minutes for questions.
Hi, this is Damien. I have a question. So how do you consider your solution versus the existing solution alternatives? How do you differentiate yourself?
When it came, I'm sorry, could you please repeat the question one more time?
Sure. How do you consider yourself different compared to other existing solutions? and how do you differentiate yourself?
Ooh, I understand now. When it comes to our solution was designed to be either easily implemented into currently existing software or also to be used as a web page. So since in such case, we're able to easily incorporate ourselves into the currently existing system rather than using Orca or Opal, which are all tasks that require you to basically write all of your tasks inside that tool only. Our goal is to use Facebook's current documents and spreadsheets that they use currently to manage things and allow you to easily upload them, and then you can search through all of the data. No work for the engineer, no work for the managers.
Okay, thanks.
Hi, I'm DJ. I have a quick question. You showed the data on the success testing, where you did the A/B testing with interns using the tool which you had versus how exactly did you do that success testing?
Thank you very much. Lovely question. I actually was a former intern at Facebook, and I just contacted some of my old managers before the competition started saying, hey, Sunday morning, I need to talk to you guys. Same for some people who are doing current internships at Facebook. I also gave them the data that we were given by our mentor at this project and gave them the same test. I just asked them to find 3 pieces of information and convey them to me as well as what team that information belonged to. And then I measured the time it took for each one to be done successfully. And as such, my task was much faster.
So you have some version of your proposed tool already in operation? Is that how you used it? Because I'm under the impression is that this is a product concept, but you're saying that this is actual working product?
It does work to a limitation. For instance, the machine learning part, in order for it to be as effective as other products, this was a basic prototype as a proof of concept to see if people could find information faster using our app. Now, ideally, we would love to have machine learning in order to make a better tag system and more effective, but we just have them test a minimum viable prototype.
So right now it's just trying to find the information, like searching through the system to find the information. Okay. Thank you.
All right, any other questions? All right, team, it looks like you've answered all the questions, so thank you very much. We are going to take a quick break. I'd like us to get back together at 3:15, and then we will resume with the next 4 teams. The next 4 teams are Blanking Box, Golf Chart, Facebook Performs, and Battery Boys. So we'll get back together again at 3:15. Thank you again very much, and I look forward to seeing you soon. Let me welcome everyone back. It's 3:15. We are going to start again with our competition in just a few minutes as we bring everybody into the room. The next team to present is Blanking Box, and we'll be getting them ready. We'll promote them up. Now, one of the things that I do want to say is that most of you realize that it takes a tremendous number of people to put this together. One of the most important things that has been accomplished this weekend is we've had a variety of mentors, and the mentors have been absolutely fantastic. They have been put together and they've been engaged the entire weekend. So this is an opportunity for us to really thank the mentors and thank them individually. If you get a chance to thank them all for all the time and effort that they put into the opportunity to work with you, because all of us have had a great time and really enjoyed getting a chance to know each one of them. All right, we all ready? So Blanking Box, go ahead and turn on your videos. And as soon as the screen is shared and you are ready to go, then we'll have an opportunity for you to get started. So we'll be sharing your screen in just a couple of minutes. And then as soon as you are ready, you may begin.
Howdy, we are the Blanking Box, and in the next slide, we will give a brief introduction. I'm Alyssa Plashik. I'm a senior industrial distribution major.
I'm Martin Vialsolo. I'm a junior mechanical engineering major.
I'm Sonia Bambavani. I'm a freshman computer science major.
I'm Melissa Sanchez. I'm a senior mechanical engineering major.
And
I'm Dylan Gay. I'm a freshman general engineering major, planning on going to mechanical.
And in the next slide, we have a brief video presentation.
Want to stay connected? With Facebook, it's more than possible. Update your status. Post a pic on Instagram. Message a friend on Facebook Messenger or WhatsApp. Send a friend request. Like a post. Shop on Marketplace. Send money. Look for a job. Check the weather. Create an event. Check the news. Design. Watch a movie. Listen to music. Play games. VR. Fundraise. Go live. None of this would be possible without Facebook's hundreds of thousands of servers around the world. Let's take a closer look at Facebook's data center racks. The biggest problem in data racks is the leakage of cool air. What does this look like? The cool air comes from the top, front, and cools the server. It intakes the cool air and expels the hot air out the back. Any open space at the front of the rack wastes this cool air. Facebook's current solution involves coating cardboard boxes in expensive materials, leaving room for improvement. Their pizza box method fills the empty space, but does not fully cover or seal the space. We have created an innovative design that is a more efficient and feasible system that can seal the space at the front of the racks, reducing energy consumption and saving millions. The blinking box.
So the main issue at hand is that Facebook is currently losing millions of dollars per year from cool air leakage. This is due to empty spaces in their data center racks. Facebook's current solution for these empty slots still allows for cool air to escape. Since cool air is introduced at the top front of the server rack, the space between the servers pulls the cool air through to the heated air before being able to properly cool the servers. We have designed a silicone sealed blinking box to fill these empty spots and increase efficiency levels. In the next slide, I will go over requirements needed for a solution. So in order to successfully create a solution, we need to follow these key requirements. Most importantly, our design must be able to prevent this cool air leakage. This means sealing off the empty slots in the racks. It is crucial that the blinking box materials meet flammability standards and fit the dimensions provided by the Facebook team. We plan to meet all of these requirements while keeping the cost under $30 per unit and using recyclable materials. And in the next slide, Martin will go over our design concepts.
All right, so we chose to split the design process up into 3 different parts. We started off with just the basic box. This alone will block most of the air trying to get in, and it's also a great foundation to really build off of and implement things that will really take the product to the next level. We also chose to make the box out of aluminum. The reason for this is because it met most of our requirements as an inexpensive, non-flammable, etc. After this, we implemented a latch system. And this was a pretty simple latch system that was just 2 springs that someone would have to retract in order to install or remove the box from the racks. And the reason why we wanted to do this is because we really wanted to make sure that the box was secured to the rack. And the reason for this is because during transportation or a natural disaster like an earthquake, for example, there is a possibility that the box could fall out of the rack and actually damage and break. So we made this latch system to make sure that doesn't happen. And then next, we finally made a silicone seal. And the reason for and we put this on the outer edge of the front face. And we did this because the box, although it does block most of the air going through the front face, there's still little gaps, especially in between the units. So this was a great solution that would really make sure that those gaps were sealed up and no air would go through the front. The silicone seal was also really good for this. It was flexible, inexpensive, and it's really easy to use. In the next slide, Dylan will talk more about the design.
So here's the aforementioned locking mechanism, the latch system. As you can see, you need to retract little tabs that will have, of course, closed area all the time. in order to protect those pin locks that you see. And if we go to the next slide, we'll see how those integrate into the rack chassis itself. We have these leftmost pictures, areas where these slots will go, where these open slots are exactly in the racks, and these pinholes that are about 5.5 millimeters in diameter where these pin locks will fit in. You just slide it in, slide this rack in, the box in, pop it and lock it, and that makes it very easy to use. Along with that, we have the front-facing F on the design here, as you can see in this white and blue Facebook design, but it gives horizontal and vertical orientation. It makes it harder to misuse, and it's very easy to use in that sense. But also along with that, I want to stress the structural integrity that these locks provide, as Martin said, as well as the silicone mold provided by this sort of like light blue area on the top, which provides a front-facing seal that'll allow for Facebook to save these key millions of dollars per year in a way, and be able to cover that open slot area with an airtight seal and circulate airflow in a way that no other product has done before, such as the front-facing seal or just the pizza box sort of solution we have right now. This will provide a much more crucial coverage in that sense. As well as the fact I want to cover, this can be integrated not just for Facebook, but also for any other network array that wants to fit these products as well. And it can also be adjusted for U1 and U2 designs, as we'll discuss. Not only is it easy to use, it's easy to make as well. And designs that are so seamlessly integrate into the rack chassis that give so much profit and so much benefit don't come by that often and need to be installed like as soon as you possibly can. If you feel to pass up on this. And also what makes it more innovative in that sense is that we're manufacturing with fewer materials in past solutions and more eco-friendly materials that allow it to drive down cost. And that can be maintained in many different ways of feasibility. In the next slide, Sonia will discuss what we need to make that happen and how we can make it more effective.
So our design is very simplistic. We only need 4 materials. First, we'll start with the aluminum, which we'll use as a base for our box, and then we'll use an adhesive to attach the silicone, which we'll use as a seal. We decided to use the ABS plastic and the aluminum combination even after reviewing many metal and plastic solutions because they comply with our requirements the best. The ABS plastic is inexpensive, recyclable, easy to machine, and very easy to use with the mold that we'll be using for our latch system because it has low melting temperatures. In the next slide, I'll be talking about our value proposition. So our value proposition is that many data centers and Facebook will be able to save at least $2 million per year, as our target price will be $25 to $30 per unit, with additional features that will be added later on, discussed in the next slide by Melissa.
Thank you, Sonia. So our blanking box has the potential to be innovated even further, saving even more money than it already can. So in the future, the team plans on evaluating the implementation of a full coverage seal. So the model would integrate a thin silicone lining surrounding every edge of the box, creating an airtight seal from all angles. The team would analyze the cost efficiency of this design in terms of saving money by completely eliminating the possibility of cool air escaping from any direction. And secondly, we would further evaluate the latch system. So the team would conduct more research to find suitable manufacturers that can provide durable materials to ensure a reliable and long-lasting product. This would ensure that the system can lock into the rack and stay there for as long as possible, minimizing the need for maintenance and repairs by the service team and further reducing costs. Additionally, the team would look into designing a blanking box that can expand from a 1-unit size to a 2-unit sized box. This would be extremely beneficial as companies would no longer have to worry about purchasing 2 different sized boxes. Instead, they could purchase the expandable box and install them according to 1 or 2 unit sized empty slots on the rack. So this would also greatly reduce the cost of shipping and the box can ship in its retracted form. And lastly, the team would conduct a detailed cost benefit analysis. So this would allow us to compare the cost of the materials needed and also compare manufacturers that provide the materials we need so that we can choose the most cost-efficient option for our design, maximizing the profitability of our products. Next slide, please. So this concludes our presentation. Thank you guys so much for listening. We really appreciate you being here, and we are now open for questions.
You finished right on time. Judges, you have 5 minutes for questions.
Thanks for the presentation. I had one question. So what were the alternatives that you that your team investigated?
So the first alternative that we investigated was the expandable design. We really wanted to implement this because we know that it would greatly reduce the cost of the product. The only problem was finding manufacturers that could provide us with the materials that we would need to be able to efficiently slide the boxes on top of one another. Also, we looked into different materials. At first, we really wanted to find some sort of plastic, maybe ABS, that we could manufacture because we know that those are cheaper than most metals. But again, that brought up problems because in the manufacturing process, there are still pores, or I guess the material has a higher level of porosity, so air still has a chance of escaping. So this is why we went ahead with the aluminum box and with the silicone seal on the front side of the rack so that the cool air can't escape in that direction.
Okay, thank you.
Mm-hmm.
Hi, this is Ying. Thanks for the presentation. So first of all, I want to point out, like in your statement, you mentioned the major issue is about the air leakage from the cold air to the hot air. And another thing actually I want to point out is it's also because of the air recirculation. Like it's possibly like the air will from the hot air goes to the cold air. So this is another purpose, like we want to have this kind of design to block the air passing through. So except that, I also have a question. So like in our data center right now, we do not have, we are not like have an empty slots there. So we actually have something like the design ready to block the air for most of the cases. I would think like a 2 million saving is not an appropriate statement. I'm wondering, like, have you have any comparison between the current design solutions and what's the advantage compared with the current design solutions?
Right, so we actually got that number, or the ballpark of that number, from the mentor with Facebook that we were working with, just because I did try to reiterate that we know that there is a solution in place. It's just right now we were told that that solution doesn't necessarily seal the front completely. There are still gaps that are still allowing for more of that airflow. And so with the seal, we were kind of told that it would be able to save more money in that sense.
I noticed that with the seal you had, that it was, I think it was just vertical, right? So I guess the question I would have would be, if you have servers that are adjacent to these boxes and your seal, as you pull out a server, won't your box kind of come out with it?
So not necessarily. The silicone seal would match the dimensions of the air gaps present between each servers. It's a very small gap. It's can't be more than 2 millimeters. So that's why it would be a very thin lining, to the point where when you do pull out the box, it would not interfere with the above or bottom servers. And also, if there are servers on the side, I know that the racks have those kind of rebars to block that. So yeah, I guess that problem can be mitigated with the dimensions of the silicone seal.
Right, and that's also, the silicone is also just very flexible, and that's one of the reasons that we have the locking mechanism to keep everything in place.
So your silicone seal would flop one way or the other?
Flexible in that it can withstand, it wouldn't flop, it would be stiff enough to be able to stand up on its own to kind of create that covering, but you know, when it's taken out, it's still stiff enough that it can stand. And also it'll be rather small, so there won't be much room for the seal to flop over.
Yeah, I think on the CAD drawing, I think we just like overemphasized it just so it was like seeable. And the actual thing is a lot smaller.
Okay, Blanking Box, thank you so much for the answers to the questions and for your presentation. We really appreciate it. The next team that will be up is Golf Chart, and we will be getting them ready to be able to present here in just a couple of minutes. I mentioned the mentors before as they were critical to the success of this overall event. I also would like to highlight and thank some of the staff that's behind this. You got a chance to interact with Professor Donnell and Don Bailey as we were working through and really pushing you to come up with some new designs and some new ways to be able to present that. Professor Donnell and I are professors here of practice here in Texas A&M University, and we teach a number of these classes. Another person that you may have encountered is Miss Erin Williams, and Erin is also one of the key elements to our overall presentations, and it gives us an opportunity to work as a team. We form a team as we go throughout all of these Aggies events, and as we're doing this, we're able to learn more and more about what is going on. All right, Golf Chart, we are ready for you, and if y'all will turn on your video, when you see your first slide come up and you're able to start talking, we will start the timer when you are ready. So take it away when you're ready, Golf Chart.
Howdy, we are Golf Chart, and I am Vivian Yu, a computer science major.
I'm Amin Sakraut, general engineering.
I'm William Zhao, computer science.
Jason Hirsch, general engineering.
Santana Gonzalez, interdisciplinary engineering.
And we are here to present to you Golf Chart. Next slide, please.
Let's see what I've got going on today. Oh, I've got to be with my manager at 4:20. Jeez, it's 4:09 already. I've got to find a golf cart and head there quick. Man, I can't find a cart and I've only got 5 minutes till the meeting's supposed to start. Finally, a cart. The low battery indicator's on, but can't be that low. I'm sure I can make it. Okay, let's see. Only 4 minutes left until the meeting starts. Wait. No way the cart's out of charge. Ah, jeez, I can't be late to this meeting. Okay, I've called maintenance, and they should be here soon. Come on, where are they? I'm already late. Finally, they're here. More than half an hour late. This really has ruined my whole day. I'm not going to be able to get any work done. How could this have been prevented? Let's go back. The solution is Golf Chart.
Next slide.
Too much employee time is lost transporting from one place to another. So how do we address this? Next slide, please. We designed a platform to optimize the efficiency of using golf carts to travel between buildings at Facebook data centers to save employee time. Next slide, please.
Facebook employees will often schedule 15-minute breaks between meetings just in case they can't find a cart or they find one with not enough battery to get from building to building. These 15-minute breaks can quickly add up, costing each data center about $500,000 a year in labor costs, which is about $7 million per year for Facebook worldwide, just in the trash. Plus, employees also lose momentum in their workday, resulting in lost productivity. Employees also can't have just virtual meetings, and they need to transportate from building to building because they'll often be bringing hardware demonstrations or tools with them that they need to present. Our solution costs about $19,000 to implement on all Facebook data centers worldwide, eliminating the need of long travel breaks. Next slide, please.
One solution which might come to mind is to just buy more golf carts. The problem is, over time, golf carts will be left abandoned and out of charge since employees are not motivated to be diligent with charging them. Well then, what if we require employees to charge the carts? Forcing employees to charge the carts would be hard to enforce and annoy employees, hurting productivity. Well then, what if we didn't have to charge the carts at all? We could just install electric roads. This has been demoed in Israel before. But it's incredibly disruptive and expensive since you have to tear up the roads to install and maintain the charging pads. Next slide, please. We decided on the following 5 requirements for our solution. Golf cart and battery levels and their location must be accessible to users. It must motivate users to actively charge the carts. There's no regular maintenance or charging required. It must be portable between multiple types of golf carts, and it must cost less than $200 per cart. Next slide, please. When coming up with our solution, considering the requirements, we considered a few different ideas. Directly monitoring the battery using a multimeter could work, but then the design wouldn't be portable to use with other models of golf carts. Estimating the remaining battery using an algorithm solves this issue. Maybe we could have the car pair with the driver's phone over Bluetooth to communicate collected data. But then if someone forgets their phone, it would mess up the whole system. Next slide, please.
Our solution involves 3 major components. We use a Raspberry Pi circuit board powered by solar panels to send location data and estimated battery percentage to a server via cellular connection. We also use optical sensor detectors to see when the golf cart is actually being plugged in and charged. And finally, our system works on any golf cart or even other electric vehicles. Next slide, please. We have 4 really cool innovative features with this product. First of all, the award system. This involves gamifying employees to park and charge golf carts, making it fun. Next, these awards are based on a manager discretion, and also Facebook already has an internal award system which we can easily integrate with. Secondly, balancing charging use. Golf Chart suggests when someone should charge the vehicle depending on weather conditions to help extend that vehicle's battery life. Third, live updates. Our system is constantly uploading data, as I mentioned, location and estimated battery percentage to the cloud. Golf Chart also updates more frequently when the golf cart is in motion and less when stationary to preserve its own separate battery life. And finally, and perhaps most importantly, we have large-scale data analytics. We use machine learning to discover insights such as when people decide to charge an electric vehicle, points of congestion, such as traffic, as well as prolonging battery life of batteries in general. These derived data sets can be sold to battery companies to predict the reliability of different battery chemistries in different environments without having to mass produce these batteries. Also, electric vehicle and transportation companies can use these insights for managing their fleets. Next slide, please.
Here's a model of our app showing nearby carts along with how much battery each one has on the left. Similarly, in the middle, you can see what happens if you swipe up slightly. On the right, you can see the leaderboard with people racking up points every time they plug in their cart. Next slide, please. Here you can see a basic design plan with the circuit board used on the left to collect data, a closed shell module on the right to withstand weather conditions. We would also be connecting a solar panel to power the device rather than having it plugged into the car. Next slide. Our design will cost $165 per cart, consisting of basic tools to run our program, such as a circuit board, solar power module, and GPS to help employees find the nearest golf cart with enough charge to take them from point A to point B. These are relatively cheap components found at almost any tech store, and our biggest cost is the solar power and battery because we want to make sure these devices last a while and don't die quickly. Once the program is created, these devices can be set up on any vehicle used by Facebook or any other data center with golf carts, or in the future, any electric vehicle.
Next slide.
Next slide, please.
Golf Chart's initial idea began as a solution to Facebook's time and money wasting problem, but we can see Golf Chart being used on any vehicle at any large data center. Its machine learning capabilities allow it to collect data on how people drive and charge electric vehicles, possibly being invaluable to Facebook and coming at next to no cost. In the end, battery charge data could become more valuable than the battery management application that was designed to solve Facebook's problem. Next slide, please. Thank you, and we'd like to open up the panel for any questions.
Thank you very much, Golf Chart. And judges, you have 5 minutes for questions. I know they're there.
Hi, so I was wondering what and whether a solar panel would be sufficient for that.
We didn't hear the whole question, or I didn't hear the whole question. Sorry.
Oh, I was wondering about the how long the battery would last, and whether a solar panel would be sufficient to power it.
So the battery would last for approximately I would say 4 to 5 days, and the solar panel would not only charge the battery, but it would feed power into the unit itself. So when there was sun, it would run the whole system, but without the sun, then it would run off the battery. And then the system would be optimized to only use power when it was needed. So when the cart was in motion, or when it needs to feed data, and other than that, it wouldn't be using much power.
Hi, this is Damien. I would like to ask, how do the user get connected to your system?
Facebook employees have their own internal logins, and it would be tied with that through like a login portal for the app. So Facebook employees would be able to log in with their existing Facebook logins.
What's the communication base of, like from this device to Facebook centralized, I believe centralized data center database?
I'm sorry, could I have you repeat the question, please?
Yeah. How do your system connect to like Facebook centralized system?
We were thinking about having Facebook host its own servers on site so that there would be less latency. And if needed, it would just be like a little internal mesh rather than over the whole internet. But otherwise, it would just be broadcast over the internet, probably encrypted end to end. But we were hoping for more Facebook on site, especially so they can collect data from other companies or devices used elsewhere.
Okay, so a mesh network is a proposal.
Yes, sir.
Okay.
So I believe your proposal was that it would piggyback off the user's phone. Is that correct? For connectivity?
So it would be running off a Raspberry Pi, and it really depends on where you'd want to implement it. So if there's not much Wi-Fi within the campus itself or where you're navigating, then you could input a SIMS card and it would have its own cellular data and pay for it that way. Or if not, it could just connect to Wi-Fi when it was being parked or when it was being drove around, because if Wi-Fi connectivity is good enough in the area. Wi-Fi, I mean, phone connectivity is also a possibility, but it's not 100% necessary.
Okay, thank you.
The users themselves use an app to connect to the information that's being fed from the cart's locations, so they can access it through a map. And we know that Facebook has tablets located around the data centers. So if they did not bring their phone, or they're short in time and they left it somewhere, they can go back and find a tablet to go ahead and look for the nearest golf cart.
Okay, judges, you have time for about one more question. Okay,
I had
golf
a quick-
chart. Oh, yes, please go ahead,
Yeah,
Darwin.
I had a quick question. Do you see any way to reduce the cost? You mentioned $165. Is that a prototype cost, or is that the cost for a generally available product?
That's the cost for generally available products to just go in store. We would probably be able to get a bulk discount to buy thousands at a time, and we could probably reduce off of the cost of the solar panel and the battery, because we looked for higher quality products. So if we can get those down to about 20 to 40, that's about half the price cut off already.
Okay, thank you.
All right, golf charts. Thank you so much for your presentation. And judges, thanks for the insightful questions. We're going to be moving on to the next team, which is Facebook Performs. And this should be an interesting description of what's going on and some interesting description of the solution that they have tackled as well. Again, let me remind you about the Engineering Incubator. For those of you who would like to continue on with your project, we would love to get you involved in the Engineering Incubator and get you engaged with us in engineering entrepreneurship. We have these kinds of activities going on, again, 3 times a semester. Aggies event is 3 times a semester. The next Aggies event that we will be hosting will be in January, and we'll be hosting it with the College of Veterinary Medicine. So if you're interested at all in solving solutions or putting together solutions for the veterinary world, we'll be working with them. I was fortunate to be able to teach a class in the College of Veterinary Medicine this past semester, where we designed the veterinary clinic of 2030. And the veterinary clinic of 2030 is going to be very different than what you see of and think of today, because of all of the technology that's going to be involved. Things like gene splicing, CRISPR technology, social media is actually a very interesting piece of a veterinary clinic as well. So there are some real tremendous solutions that you have available and that you might be able to put together if you're interested in participating in the Aggies event for veterinary medicine. We are ready to go with Facebook Performs. And as soon as we share your screen and it's available, you're more than welcome to get started. And we look forward to hearing your presentation. Facebook Performs.
Hi, my name is Nick McDonough, and I am a sophomore computer science major.
Hi, my name is Ashok Mahapin, and I'm a junior computer science major.
Hi, my name is Mary Faith Mitchell, and I'm a sophomore computer science major.
Hi, I'm Christopher Chamberlain, and I'm a freshman in general engineering.
And we are Facebook Perform. Next slide.
We've all been there, spending countless hours in meetings trying to get everyone on the same page. While time is money, it is also our sanity. Employees spend many hours working towards their goals and assigned tasks, along with countless more creating and aligning goals. This is precious time that should instead be spent on accomplishing goals. The goals of today are evaluated during long, arduous meetings. Beyond these meetings, they live in confusing, crammed spreadsheets. In a larger company, equally as important as generating goals is combining and aligning goals. Some employees spend up to 5 hours per week in meetings trying to align their goals. The solution to this problem is Facebook Perform. Using both a mobile app and desktop website, you can fill in details relating to your goal, such as the description and timeline. Our software uses weighted document term matrices and topological sort algorithms to align and prioritize your projects. Natural language processing and machine learning ensures you get the most accurate results. Once a goal has been created, it will show up in the goal dashboard, along with the goals created by other teams. This makes it easy to keep track of what each division of your company is working on. Facebook Perform will also generate organization charts to help organize and align goals. Don't spend unnecessary time in meetings. Perform more, waste less with Facebook Perform.
So at companies all across the world, employees are spending too much time in meetings analyzing and aligning goals between departments. I'm sure no one here wants to spend long hours in Zoom meetings. According to Facebook employees, spending time in meetings, analyzing and aligning goals is the #1 time waster. Employees can spend up to 5 hours of meeting time per week analyzing and aligning goals. That's about 1/8 of their time being wasted. We want to create an application to reduce the time being spent in these meetings. Next slide, please. So the requirements for application would first be to shorten time in goal alignment planning meetings by 50%. The second would be to add no time for employees inputting goals. The third would be to have no more than 8 automated notifications in a day to prevent annoying the manager or the employee. The fourth would be to provide 3 different categories from which the goals can be visualized, and fifth, to be integrated into the company within the time frame of 6 weeks of creation. Next slide, please. The current solutions that are out there that don't really solve the problem, that are related to this problem but don't really solve it, are Smartsheets, which is like an Excel spreadsheet for setting goals, and other project management tools like from Microsoft, Asana, and Atlassian, which focus on improving performance in specific departments rather than other departments within the organization and the organization as a whole. Next slide, please.
Okay, sorry. We considered several approaches to solving this problem. One included a goal alignment application to improve the alignment of goals across different departments by comparing the similarities. Another concept analyzes task dependency to provide users with information discovered. A goal generator to assist in the creation of SMART goals was also considered, as well as a process tracking software, which can be used to see the current progress towards a goal. Since there are existing solutions for goal generation and progress tracking, we focused on solutions number 1 and 2. Next slide, please.
Now to introduce Facebook Perform, an application that simplifies the task of goal alignment. The first feature includes goal similarity detection, loosely based on the technology used by Turnitin, a plagiarism detection software. Facebook Perform analyzes goals for dependencies. Task dependencies represent the order of tasks to be completed. For example, training employees on a new software is dependent on purchasing and installing the new software. Facebook Perform analyzes the description of the goals inputted in order to find these dependencies. Next slide, please. Facebook Perform offers both a mobile and web platform. Key contacts for the project can input the goal, as well as various information about the goal, in a very similar format to what Facebook currently uses today, as shown here. Next slide, please. There are 3 perspectives used to illustrate similarities: tag, interdepartment, and across departments. Managers or any team members can look at the project goal and check the similarity with other projects within the company. This allows for further collaboration between departments and teams working on similar goals. Next slide, please. Finally, the project dashboard displays project goals that are dependent on the current goal. Next slide. A link can be clicked to generate a Gantt chart or a program evaluation and review technique chart, which are commonly used to analyze resources and time allocated towards a goal. Next slide, please.
Our project requires 2 main algorithms, one for the alignment and one for the task dependency analysis. The alignment algorithm uses word association to create what we call a bag of words. This is similar to the word maps that you see here, where the main word is in the center, and then the words that are further away and smaller are less related to that word. These bags of words are then compared to the bags of words from other goals to create a percentage alignment. Let me show you how it works on the next slide. So, for example, the statement Facebook Perform will help save time becomes the individual words Facebook, perform, save, and time. Each of these words gets its own bag of words, which is placed into the matrix as shown here. And this matrix then gets compared to the matrices from other goals to create a percentage alignment. Next slide, please. What really makes our innovation unique is the use of weights, natural language processing, and the adaptability of our algorithm. Our algorithm uses weights based on the importance of words, as well as how similar that word is to the original goal statement. Additionally, we use natural language processing to generate the bag of words, which is unlike any solution that is out there on the market today. Finally, our solution is adaptable. We're going to use value-based reinforcement machine learning to evaluate the successes and failures over time of our solution and adapt over time. Next slide, please. The second algorithm is the task dependency analysis. For this task, the user gives the estimated time to finish the task as well as the goal and any deadlines for the goal. These are then placed into a spreadsheet, and then the text for the goal is analyzed to determine if there are any prerequisites or co-requisites for the current goal. These are then sorted using a topological sort, and the results are displayed by listing the pre and co-requisites in addition to the charts discussed earlier. Next slide, please.
What would have previously been 2 to 5 hours per week for goal alignment would now be around less than an hour per week for goal alignment. This would help enforce the 70% productivity rule throughout the whole organization and would be integrated into the company. I'll go to the next slide, please. So like it would be able to help enforce the 70% productivity rule throughout the whole organization and would be integrated into the company within the time frame of 6 weeks. Next slide, please. So though our application is intended to improve the efficiency of Facebook, our application has other uses as well. Our application's algorithm can be used, can be integrated into the existing algorithm used in social media platforms to better improve the matching of related profiles and posts, as well as the priority of posts and profiles displayed for the user. As well as in the future, our application can be sold to various other companies wanting to reduce their time being spent planning, aligning and analyzing their goals in their meetings. And overall, our application does not only improve the efficiency and performance in terms of interior of the organization, but also increases profits in other aspects of the business and also when being sold to other companies. Thank you for listening to our presentation, and we're happy to answer any questions you have regarding Facebook Perform.
Facebook Performs. Thank you so much. And judges, you have 5 minutes for questions.
So I have one question. So I think the use of natural language processing is pretty innovative, but it requires lots of data sets or a huge data set to be very effective, right? So we are not making millions and millions of goals every year as a company. So how do you propose we make the NLP very accurate, even though you're not going to get as much data?
So even though we're not going to get as much data, we already have a baseline of NLP data sets that are already out there. And we're going to make use of those to help build ours to help align the goals together without using too large of a data set.
Okay, thank you.
Hi, this is DJ. All of you presented very comprehensive list of features, which are very impressive. My question is, if you had to start with a minimum viable product, what would be your view of something which has to be minimalistic feature but absolutely necessary? How would you define that product?
Mary Faith, I think you can take this one.
Yes. So I think that the most important feature that we would be providing to users is the input side. So that's where you can input all the details regarding your project. And then from there, there's also the page where you can view all the current projects and along with similarity percentages based on the information that users are inputting.
Okay, thank you.
On your last slide, you had something about next steps and talking about like expansion on social media platforms. I guess my question is, why social media platforms? Like what ties this platform to social media?
Because like since this product is application intended for like Facebook, like primarily like for sure right now, it would be like for Facebook to like is primarily involved in the social media like industry with Instagram and Facebook and those applications, social media platforms. So the algorithm we use can help like the initial like existing algorithm that we use are utilizing in this algorithm to match the similarities between.
So the matching algorithm can be taken from our application and implemented within Facebook's other applications in social media.
Oh, I see.
Thanks for the presentation. I have a question. So you have a slide comparing the time saving from maybe like 5 hours to 1 hour. How do you get the data?
So like we estimated like a 50% in time saving. So how we got the 50% was we looked at the major steps that are being performed in like the general like meeting for aligning and discussing the goals. And we took like specific, like we reviewed like the time it would take for each step. And we looked at what our application meets and what our application doesn't. For example, prioritizing goals, our application would solve that, but it does not solve like discussing the overall mission of the company. So like by taking into account like what our application meets and what it doesn't, we took in the percentages of each time based on the overall time of the times that we calculated, and we got the percentage of 50%, and we incorporated that into the 5 hours to 2 to 5 hours to reduce to 1 hour.
Thank you.
Okay, well, it appears that y'all have answered all of the judges' questions. So thank you very much, judges. And thank you very much, Facebook Performs. A great presentation, and really enjoyed seeing your innovative solution. All right, we're going to be getting ready for the last presentation of the day, and this is Battery Boys. Battery Boys will be wrapping up, and then we'll take a short break after Battery Boys as we're tabulating scores. Again, I'd like to highlight VJ for his continued support and the support of Facebook. But I also want to recognize that VJ is a graduate of Texas A&M University, and many of our mentors were graduates of Texas A&M University as well. So what a great opportunity for you for you to be able to make a difference in the world. VJ gave a great presentation early on in the very opening and talked about how Facebook is in the process of really implementing and helping the world communicate and connect. And I think that's very important. So when you're looking for a company and you're looking for some place to make a difference, make sure that you have an opportunity to make a huge difference in the world. And that's what we've been pushing you all along, is how are you going to change people's lives? And it is absolutely easy to see how Facebook has changed people's lives. All right, Battery Boys, we are ready for you as soon as you see your screen show up and you're ready to start, then we will start the timer. Again, take it away, Battery Boys.
Howdy, we are the Battery Boys. Next slide, please.
Hello, my name is Minkoi Win. I'm an MXCT major and I'm class of 23.
Howdy, I'm Jacob Thomas. I'm a general freshman engineering and I'm part of the class of 2024.
Hi, my name is Jay Leonard. I'm a computer science major. I'm class of 2022.
Howdy, my name is Adam Pamaron. I'm an electrical engineering major and I graduated class of 22.
My name is Nomer LeBron. I'm an electrical engineering major and I'm class of 23.
Hi, my name is Justin Bonyoma, electrical and computer engineering, class of 2022.
Next slide. When batteries are overcharged, they can begin to balloon or inflate, also known as swelling. The battery swelling, if not detected, can lead to a chemical fire or a release of toxic gases. This could result in serious safety hazards if not properly addressed. Facebook has racks of different phones constantly testing their numerous apps. This requires charging at all times, which in turn leads to battery swelling. Currently, there is no automated system in place to detect the swelling of the batteries, which if left unattended for too long can lead to serious fire hazards. The loss of a data center would be a catastrophic loss financially, as well as pose a great risk to the personnel on site. We've designed a modular system that solves the problem of overcharged phone batteries swelling and causing a fire hazard in the data centers if not detected and replaced. With our new innovative design, we eliminate the risk of swelling-induced fires and bring about peace of mind for our customers. Next slide. We are solving the problem of overcharged phone batteries swelling and causing safety hazards such as fires or the release of toxic gases within these data centers. You may not believe these to be a pertinent issue, but the rate at which batteries at Facebook swell is alarmingly high. Next slide. There are approximately 3,000 phones currently inside Facebook's data centers, with plans to expand in the near future. The phones normally arrive to the center in batches, meaning they also begin to swell in groups, further raising the threat level of a fire. These phone batteries have a life cycle of 1 to 2 years due to the constant charging, which requires them to be checked and replaced weekly. Next slide.
As Facebook grows, more developers will be hired and the need for phones to test performance metrics on working projects increases, with the plan to deploy 10,000 phones in data centers by 2022, with a projected growth of 20% every year. Next slide, please. With that many phones deployed, the frequency of phone replacements will be in days instead of weeks, making it harder for technicians to spot irregularities with each phone. Next slide, please. This is where our design requirements come in. We want to create a system that detects battery swelling at any time of the day. We want our system to have a universal fit on any rack design and work with multiple phone brands. Additionally, we want it to reliably communicate sensor data efficiently and scale up to Facebook's current and future server rack models. Lastly, we want our system design to have minimized obstruction to allow Facebook technicians to use the phone. Next slide, please.
We wanted our system to be innovative, so we decided to give it a little sass. Our design philosophy, SAS, stands for simplicity, accessibility, and scalability. You may be asking yourself, how is this innovative? Current solutions involve an internal sensors, which is a hassle to install and violate device warranties. Our solution, however, is completely external, avoiding these issues. Next slide, please. This is our first design sketch. And as you can see, it's quite simple. However, keeping it simple has a few benefits: ease of manufacturing and use. Next slide, please. We were able to create a small mock-up of our design with the materials we had on hand. And as you can see by the GIF, accessibility is a key design element that we were able to incorporate into design. We want to keep the system as user-friendly as possible for Facebook technicians. Next slide, please. Lastly, and most importantly, we want to keep the design modular for different phone generations and scalable for current generation and next generation phone racking systems. As you see by the image, there's an iPhone X to the right and an iPhone 7 Plus to the left. This demonstrates that our solution can be implemented right now and can be in use for years to come. Next slide, please.
For our proof of concept, we have a graph here to show how each individual stretch sensor interacts with databases and web applications that technicians can get a hold of. So in each server stack, we have the stretch sensors, which are physically on the device itself. Each of these sensors will connect to an I2C circuit, which will allow for 128 connections, each with a 7-bit address that is connected to a Raspberry Pi. If you wish to have a higher density of phones within that server stack, you can increase the number of Raspberry Pis and I2C circuits you will have, and this will increase at a rate of 128 connections per Raspberry Pi. All these Pis will be addressed, and all the data will be sent to the head node. The head node will send all of its data once a week to the Scuba database, which is an internal database that Facebook currently has, which contains system information. This data can then be pulled by technicians with Scuba queries or custom applications written by the technicians themselves. You only need to pull these stretch sensors approximately once a week, as there's no need to pull these like every second, as swelling of the battery is a slow issue that appears every 2 years, but you need to check weekly due to the scale size, due to the amount of phones there are. Next slide, please.
So a stretch sensor is an electrical conductor for which the resistance changes when it's deformed. As you have seen from the previous slides, the stretch sensor is wrapped around the phone. So when the battery expands, the phone is deformed, and so is the stretch sensor. This deformation change causes the change in the resistance of the stretch sensor, which is detected using the voltage across the stretch sensor. The information is sent to the signal processing unit, which has a Raspberry Pi. The Raspberry Pi then forwards the information to the databases, and then the notification is sent to the people responsible in a nick of time, and then time is saved and lives are saved. Next slide, please.
More companies such as Google, Apple, Cobiton, Microsoft, and other Facebook partners, where batteries are constantly being tested, could use our solution to ensure that fire and other hazards are not started by swollen batteries. Additionally, as batteries become more prevalent in our society, our solution could be easily adapted to fit other devices, such as solar cell batteries or even electric car batteries, to ensure the safety of customers and consumers. Next slide, please.
Okay, thank you, Battery Boys. Judges, you have 5 minutes for questions.
So I have a quick question. So the stretch sensor would be able to tell you when the phone is expanding. How would you correlate that to when the phone is actually getting into a bad situation or could potentially create a safety hazard?
When the stretch sensor is deformed, it will send a signal to the Raspberry Pi. We are scaling these stretch sensors to detect the amount of the phone, how much is deformed. And then we can use the data to determine if the phone is out of shape, like it needs a replacement or something fun is going on with the phone.
Okay, thank you.
So how much stretch is problematic? Is it like 1 millimeter, 2 millimeters? And then along with that, like your stretch sensor needs, I guess it needs to accommodate a lot of different phone models, both width and the thickness. And some phones like vary quite a bit in thickness. So how would that adjust for it?
Yeah, we are putting into account the scaling. We are thinking of using digital to analog digital converters to see how much is stretched, because this being stretched, that means it also being worked with the resistance and the voltage we're measuring. Once the amount of voltage we're measuring can be scaled with how much is stretched, then we can determine how much like the phone, how much of the battery has expanded, and then by that we can tell if by the thickness of the phone, we can say maybe it's an iPhone, let's say 8, which should be more than certain millimeter, and then we come to find, oh, it's more than that. Then we can determine this phone is deformed.
So basically, each sensor, like the sensors, you're measuring capacitance with it, and as the stretch sensor is stretched, the capacitance increases because it takes more current to run the charge through the sensor, and that's basically what you're measuring. So you just have to initially, and these sensors comes in different sizes, so you can measure, you can just use it for whatever phone you want, just because you can get different sizes of the sensors, and you you just have to take like an initial calibration measurement, and then you can, if the capacitance increases, you know that the battery is swelling because it's stretching the sensor, and that's basically how it works.
Hi, I'm DJ. I have a quick question. I don't know much about the expansion of the batteries in the phones and what kind of failure rates have been observed with billions of phones sold so far. So can you provide some data on the reliability, which people already know about these phones? The thing which I'm trying to understand is with, let's say, 20,000 phones deployed in a data center by 2022, I'm trying to estimate what's the probability of a failure, based on existing data, which you might be already knowing.
So from what we've been told, some phones swell by themselves. In some weeks, they even swell in batches, and they happen from a weekly basis. So there's not really a specific estimate as to how many phones swell. But as the phones scale up, I would imagine that it would happen much more regularly.
Also, the swelling, it's inherent in the nature of lithium batteries, so it is an unavoidable issue. It just comes with old lithium-ion batteries. And the reason the batteries swell is because each battery is hermetically sealed, and once they get old, charging just creates gas within the battery, causing it to swell, which causes the puffing up and potential leak of gases and / explosions. So it's an unavoidable issue, so you have to measure for it.
Right. Yeah, I understand. I just wanted to, learn something in terms of the failure rates. If you guys know, is it how many million hours of failure rate, which
Yes.
people have already measured, companies which produce phones, and these phones are being sold by, millions and millions of units every year for over the last 10 years. So I'm sure there is some data from companies like Apple and others on what kind of failure they observe.
Yeah, so we were talking to Matt about this, and he says when Facebook purchases phones, they hope to get a 3-year life cycle out of them, but that's never happened. This is mainly just due to the fact that this is an enterprise use case for a consumer product. So you're typically only going to get like 2 years, if at the most, of life out of each of these devices, just because of the heavy use of the batteries. So that's typically the life cycle you're going to look for in these phones.
Okay, Battery Boys, thank you so much. That's been 5 minutes of questions, judges and Battery Boys. We certainly appreciate it. We appreciate all of the presentations that you have been putting together and all of the outstanding solutions and presentations that you have described during today. We're going to take a short break, about a 5-minute break, to finish tabulating all the scores, and we will be right back and announce the winners. Again, the process is that we will elevate the 3rd place team, and then we'll elevate the 2nd place team and the 1st place team. And please turn your videos on when we elevate you to a panelist so that we get a chance to congratulate you. Thank you very much, and we'll be back in about 5 minutes.